All right, let's dive into your EEG Data Viewer project. It's a Flask web application for visualizing and analyzing EEG data, which is pretty cool. Your HTML layout includes dropdowns to select various parameters like EEG ID, expert consensus, and patient ID, and you've integrated Chart.js for data visualization. The JavaScript fetches and populates data, updates charts, and handles user interactions. Technical details. 1. Backend, Python with Flask. You've set up routes to fetch EEG data, sub-IDs, consensus options, electrodes, patient IDs, related data, spectrogram IDs, and spectrogram data. Data is read from a CSV file and Parquet files, making good use of pandas for data manipulation. There's a clear separation of concerns, with each route handling a specific part of the data fetching process. 2. Front-end HTML, CSS, JavaScript. Dropdowns are dynamically populated based on the dataset. Chart.js is used for rendering EEG data, which is a good choice for interactive charts. Event listeners are used to trigger data fetches and updates based on user selections. 3. Data handling. EEG data and spectrogram data are being fetched and displayed. The spectrogram data is displayed for different sides, LL, RL, LP, RP, which indicates attention to the multidimensional nature of EEG data. Possible issues and future improvements. 1. Error handling. While there is some basic error handling in the JavaScript fetch requests, more robust error handling could be beneficial, especially on the back end. 2. Performance. If the dataset is large, fetching and processing data might be slow. Consider optimizing data queries or implementing caching. 3. User interface. The UI is functional but basic. Enhancements in the layout and design could improve user experience. 4. Data visualization. More interactive features in the charts, like zooming and panning, could make it easier to analyze specific data points. 5. Security. Ensure that there are proper security measures for data handling, especially since this involves patient data. 6. Code organization. The JavaScript functions are quite long and handle multiple tasks. Breaking them into smaller, more focused functions could improve readability and maintainability. 7. Responsive design. Check if the application is responsive and works well on various devices and screen sizes. 8. Data validation. Ensure there's proper validation on the data being processed. This is crucial, especially for medical data like EEGs. Overall, your project seems well structured with a clear focus on functionality. The future improvements mainly revolve around enhancing the user experience, optimizing performance, and ensuring robustness and security. Keep up the good work. I see two primary issues you're encountering: slow loading of EEG IDs in the drop down menu and the absence of spectrogram display on initial page load. Let's address them one by one. Slow loading of EEG IDs. This could be due to a few reasons. 1. Increased data size. If the dataset has grown significantly, the time to fetch and render the IDs will naturally increase. 2. Network latency. If the data is fetched from a remote source, network speed can impact loading time. 3. Inefficient data fetching. If the entire dataset is being loaded to extract EEG IDs, it might be causing unnecessary overhead. 4. Client-side rendering. Rendering a large number of options in the dropdown might be slow, especially if it's not optimized. Possible solutions: paginate the data. Load a limited number of EEG IDs initially and fetch more as needed. Indexing. Ensure your dataset is indexed properly, especially if it's a large dataset. Optimize query. If you're using a query to fetch the EEG IDs, make sure it's efficient and retrieves only the necessary data. Client-side optimization. If the bottleneck is on the front end, consider optimizing the way the dropdown is populated. Virtual scrolling or lazy loading could be effective. No spectrogram display on initial page load. The absence of the spectrogram might be due to: 1. Data fetching logic. The spectrogram data might not be fetched initially, or the logic to display it might not be triggered on page load. 2. Default selection issue. There might be no default selection triggering the spectrogram fetch. Possible solutions: initialize with default data. Set a default selection that triggers the fetching and displaying of the spectrogram data on page load. Check the JavaScript logic. Ensure that the logic to fetch and display spectrogram data is correctly integrated into the page load event or the relevant event handler. For a more detailed analysis, I'd need to look at the specific parts of your code handling these functionalities. For now, these suggestions should give you a starting point to debug and optimize your application. To address the slow loading of EEG IDs and to ensure that the dropdown is populated right after the page is loaded, you can consider a few modifications and optimizations to your JavaScript code. 1. Asynchronous data loading. Your current setup already seems to be using asynchronous calls, fetch. However, you might want to review how the data is being fetched and processed on the server side. If the dataset is large, consider implementing server-side pagination or filtering to reduce the initial load. Number 2, optimize DOM manipulation. Repeatedly updating the DOM in a loop, like when you're appending options to the dropdown, can be slow. A more efficient approach would be creating a single string or document fragment containing all options and then appending it to the DOM. 3, pre-fetching data. Fetch data before it's needed. You can start fetching the EEG IDs as soon as the page starts loading, even before the user interacts with the dropdown. Here's how you can modify the populate dropdown function for optimization. JavaScript async function populate dropdown API endpoint dropdown ID. Try const response equals await fetch /$ API endpoint. Const data equals await response.json. Const dropdown equals document get element by ID dropdown ID. Let options HTML equals. Data for each item equals let value text. If type of item object. If dropdown ID equals sub ID. Value equals item.eeg sub ID. Text equals sub ID item offset item.label offset seconds. Else value equals item.id. Text equals item.value. Else value equals text equals item. Options HTML option value text option. Dropdown.inner HTML equals options HTML. If dropdown ID equals sub ID, update label offset display data. Return data. Console.error error populating dropdown error. This approach creates a string of all option tags and then sets the inner HTML of the dropdown just once, which is more efficient. Regarding the issue of the dropdown not being populated until clicked, the code already seems to attempt populating the dropdowns on DOM content loaded. If this isn't working as expected, you might want to check the network requests in your browser's developer tools to see if the request for EEG IDs is being made and how long it's taking. The server-side code to ensure it's handling the requests efficiently and quickly. The size of the data being fetched. If it's very large, consider implementing server-side search filtering. Remember, the more data you try to load at once, the longer it will take, so fetching smaller chunks or only what's necessary can greatly improve performance. Your application seems well structured for displaying EEG data and their corresponding spectrograms. To address the issue of spectrograms not being loaded correctly, we need to check two things. Firstly, the backend code that fetches the spectrogram data, and secondly, the JavaScript code that requests and displays this data. Checking the backend, Flask for spectrogram data. Fetching your Flask backend has an endpoint /fetch spectrogram, which is supposed to return spectrogram data. Here's a brief outline of what to check. 1. Endpoint functionality. Make sure the endpoint /fetch spectrogram correctly accesses the spectrogram data. Given the dataset structure, it should read the correct .parquet file and return the relevant data. 2. Data path and file reading. Ensure that data path is correctly set and that the files exist at the specified location. Also, check for any issues in reading the parquet files. 3. Error handling. Check the Flask server logs for any errors or exceptions when this endpoint is hit. It could provide clues if something is going wrong in the data fetching process. Checking the JavaScript code for data display. In your JavaScript code, the function fetch and display spectrogram is responsible for fetching and presumably displaying the spectrogram data. Here are some areas to focus on. 1. Correct API call. Make sure that the API call to /fetch spectrogram is correctly constructed and executed. Verify that spectrogram ID and side parameters are correctly passed. 2. Response handling. Check how the response from the API is processed. Make sure that the data is received correctly and in the expected format. 3. Display function. You have a console log indicating spectrogram data, but it's unclear how this data is actually displayed on the page. Ensure there's a function, possibly display spectrogram, that correctly renders this data on the canvas or as desired. 4. Error handling in JavaScript. Check the browser's console for any errors when the spectrogram data is fetched. This can give clues if there are issues in the API call or data rendering. Debugging tips. Use console.log in JavaScript to print out variables and responses at various stages to ensure everything is working as expected. In Flask, you can print statements to the console to check if the data is being read correctly and what is being returned by the // fetch spectrogram endpoint. By methodically going through these checks, you should be able to pinpoint where the issue lies, whether it's in the data fetching from the backend or in the front-end JavaScript handling that data. The issue seems to be that the side parameter is not being used correctly in the /fetch spectrogram endpoint in your Flask application. This parameter is crucial for selecting the correct column from the spectrogram.parquet file. Let's address how you can modify the endpoint to correctly utilize the side parameter and fetch the appropriate spectrogram data. Modifying the Flask endpoint. 1. Validate side parameter. Ensure that the side parameter matches one of the possible column prefixes in your dataset: LL, RL, LP, RP. You can do this by creating a list of valid sides and checking if the passed side is in this list. 2. Dynamic column selection. Once you have validated the side, you need to dynamically select the columns from the data frame that start with this side. In your dataset, each side seems to have multiple frequency bands, like LL 0.59, LL 0.78, etc. You need to fetch all columns corresponding to a particular side. 3. Fetch data. After determining the correct columns, fetch the data from these columns and format it appropriately for your front end to display. Here's a revised version of your Flask endpoint that incorporates these changes. Python at app.route/fetch spectrogram. Spectrogram ID equals request.args.get spectrogram ID. Side equals request.args.get side. Valid sides equals LLRL LP RP. List of valid sides if not spectrogram ID or not side or side not invalid sides. Return JSONify error. Invalid or missing spectrogram ID or side. 400 try, df equals p to read parquet, os.path data path, train spectrograms, f spectrogram ID, parquet. Select columns that start with the specified side. Side columns equal for col in df.columns if col.starts with side. If side columns, data equals side columns.filna, none. To_dict orient equals list. Replace none with none. Return JSONified data, else return JSONify error, side not found. 404, except file not found error, return JSONify error, file not found, 404. Notes: this code snippet assumes that each side, LL, RL, LP, RP, has multiple frequency bands and fetches all the relevant columns. It replaces none values with the string none to maintain JSON compatibility. The data is returned in a format where each key is a column name and the value is a list of the column's data. After making these changes, your Flask endpoint should correctly handle the side parameter and return the appropriate spectrogram data. Ensure that your front end is prepared to handle this data format and display it correctly. Looking at your JavaScript code, you seem to be on the right track in terms of fetching and displaying data. The modifications to the Flask endpoint I suggested earlier will help ensure that the correct spectrogram data is retrieved from the server. Let's take a closer look at your fetch and display spectrogram function to make sure it integrates well with the modified backend. Analyzing fetch and display spectrogram function. 1. Fetching spectrogram data. The function makes a request to the /fetch spectrogram endpoint, passing spectrogram ID and side as query parameters. Ensure these values are correctly acquired and passed. 2. Handling the response. After fetching, you check if the data is present and proceed to call display spectrogram. It's crucial that display spectrogram is designed to handle the data format sent by the server. 3. Error handling. You've included error handling, which is good. This will help in debugging if things go wrong. Suggestions for improvement. Ensure data compatibility. Make sure the data structure returned from the Flask endpoint matches what display spectrogram expects. For example, if display spectrogram expects an array, the server should return an array. Debugging. Use console.log to print out the data received from the server to ensure it's in the expected format. Handling absence of data. If no data is found, data.length equals 0, consider how this should be handled in the UI. Should there be a message indicating no data is available? Refactoring for readability. Consider refactoring your code for better readability. For example, using async await syntax can make asynchronous code easier to read and maintain. Example of improved fetch and display spectrogram. JavaScript async function fetch and display spectrogram. Spectrogram ID side. Try. Const response equals await fetch slash fetch spectrogram. Spectrogram ID equals spectrogram ID and side each side. If response.ok, throw new error response not ok. Const data equals await response.json. If data and in data.length 0, console.log spectrogram data, data, display spectrogram data side. Else, console.error, no data found for spectrogram. Optionally, update the UI to indicate no data is available. Catch error, console.error, error fetching spectrogram, error. Optionally, handle this error in the UI. This modified function uses async await for better readability and includes comments suggesting where you might want to add UI updates. Displaying spectrogram data. Ensure that display spectrogram is correctly set up to display the spectrogram data. You might need to transform this data into a format suitable for whatever charting library or visualization tool you're using. This often involves reshaping the data, scaling it, or adjusting its format to fit the needs of the visualization tool. From your description, it seems like the fetch and display spectrogram function is being executed, but it's not finding any data to display. This could be due to several reasons. 1. Incorrect spectrogram ID or side parameter. Ensure that the spectrogram ID and side you are passing to the fetch and display spectrogram function are correct and correspond to valid entries in your dataset. 2. Backend data retrieval issue. There might be an issue in the way the backend is fetching the spectrogram data. Double-check the logic in your Flask route/fetch spectrogram. Make sure the spectrogram ID and side parameters are being used correctly to retrieve data from the Parquet files. 3. Data format mismatch. The format of data returned from the backend might not be what your frontend expects. Since the sample response from your server looks like an object with keys like LL0.59 and arrays as values, make sure the frontend can handle this format. 4. Frontend display logic. The function display spectrogram that actually renders the spectrogram needs to correctly interpret the data it receives. If the data structure is different from what this function expects, it will not be able to display the spectrogram. Debugging steps. 1. Check network response. Open your browser's developer tools, look at the network tab, and check the actual response received when the /fetch spectrogram endpoint is called. This will give you a clear idea of what data is coming from the server. 2. Console log. Print out data right after you receive it from the response in fetch and display spectrogram. This will help confirm whether the data is present and in the expected format. 3. Backend data retrieval validation. Test the Flask endpoint independently, perhaps using a tool like Postman or a simple Python script, to see if it returns the correct data for given spectrogram ID and side values. 4. Validate display spectrogram logic. Ensure this function is designed to handle the structure of data it's receiving. It might be expecting a different format, or there could be a logical error preventing the data from being displayed. Mover 5. Error and exception handling. Add more detailed error logging in both the backend and frontend. This can help pinpoint where the process is breaking down. By following these steps, you should be able to locate where the issue lies, whether it's on the server-side data fetching, the data format, or the front-end rendering logic. To restructure your JSON file to group data based on region, and within each region by frequency, you can modify your Flask endpoint to format the data accordingly. The aim is to organize the data in a more hierarchical manner that reflects the regions, LL, RL, LP, RP, and then lists the frequencies under each region. Here's a suggested approach to reformat the data. 1. Parse and group data by region. In your Flask endpoint, after retrieving the data from the Parquet file, group the data by region. Each region should then contain an array of objects, where each object represents a frequency and its corresponding values. 2. Reformat the data. Create a new data structure that aligns with this grouping. Here's an example implementation based on your provided endpoint. Python at .route/fetch spectrogram, def fetch spectrogram, spectrogram ID equals request.args.get spectrogram scoid, side equals request.args get side, valid sides equals LLRLLPRP. List of valid sides. If not spectrogram ID or not side or side not invalid sides, return JSONify error, invalid or missing spectrogram ID or side. Try df equals pd.read parquet os.path.datapath train spectrograms f spectrogram ID parquet. Prepare the data structure for grouping. Grouped data equals region for region invalid sides. For col in df.columns, for region invalid sides, if col.starts with region, frequency equals col.split scroll 1. Grouped data region frequency equals df col filne none dot tolist. Return JSONify grouped data. Except file not found error. Return JSONify error file not found 404. In this code, we first initialize a dictionary grouped data with keys for each region, LLRL-LPRP. Then for each column in the data frame, we check which region it belongs to, extract the frequency, and then add this data to the corresponding region in our grouped data structure. This will produce JSON data. To update the fetch and display spectrogram JavaScript function to handle the new data structure, we need to adjust how it processes the data returned from the server. The function will need to iterate over the regions and frequencies, and then display or process the spectrogram data accordingly. Here's an example of how you might update the function. JavaScript async function fetch and display spectrogram, spectrogram ID, try const response equals await fetch flash fetch spectrogram bas spectrogram ID. If response.ok, throw new error, response not ok. Const group data equals await response.json. For const region frequencies of object.entries group data. For const frequency values of object.entries frequencies. Console.log region.region frequency values. Here you can call a function to process or display each frequency's data. For example, /display frequency data region frequency values. Catch error. Console.error error fetching spectrogram error. Optionally, handle this error in the UI. In this updated function, 1. The data is fetched from the /fetch spectrogram endpoint using the spectrogram ID. 2. The JSON response is expected to be an object with regions as keys, each containing an object with frequencies as keys. 3. The function iterates over each region and within each region over each frequency. 4. For each frequency, you can then process or display the data as required, e.g., display frequency data is a placeholder for whatever functionality you need to implement. This function now handles the new hierarchical JSON structure and provides a clear path to process or display the spectrogram data based on region and frequency. It looks like the issue is arising from the backend response not being okay, HTTP status 400, which suggests a problem with the request parameters or the way the backend is handling the request. First, ensure that the request to the server is correct. The error log suggests that the spectrogram ID is not being recognized correctly by your backend. The request to fetch spectrogram with a spectrogram ID should match exactly what your backend is expecting. Here's a revised version of your fetch and display spectrogram function with additional error handling and logging to help diagnose the issue. JavaScript async function fetch and display spectrogram ID, try. Const URL equals /fetch spectrogram ID equals spectrogram ID. Console.log requesting spectrogram data from $URL. Const response equals await fetch URL. If response.ok, console.error, response not ok. Status $response.status. Throw new error, response not ok, status response.status. Const group data equals await response.json. Console.log received group data. For const region frequencies of object.entries group data. For const frequency values of object.entries frequencies. Console log region frequency values. Process or display the data as required. Example, display frequency data region frequency values. Catch error, console.error Error fetching spectrogram, error. Handle this error in the UI if needed. Before you run this function, make sure the spectrogram ID is valid and exists in your database. The 400 status code often indicates a bad request, which could be due to an incorrect or missing parameter. Additionally, review your Flask backend to confirm it's correctly parsing and using the spectrogram ID parameter, and the logic for fetching and sending the spectrogram data is correct. Also, ensure that the Parquet file corresponding to the spectrogram ID actually exists in your file system. From the information and the screenshot provided, it seems like your chart is only displaying the data for one frequency, 9.96 Hertz in this case, rather than the entire spectrogram. If you want to display the full spectrogram, which typically includes a range of frequencies, you would need to adjust your charting logic to either display multiple lines, one for each frequency, or to use a type of chart that can display two dimensions of data at once, such as a heat map. Given the context, a heat map might be more appropriate for visualizing spectrogram data, as it represents how the power of various frequencies changes over time. Unfortunately, Chart.js, which seems to be your charting library of choice, doesn't support heat maps out of the box. You could use a line chart for each frequency, but this might not be practical if there are many frequencies. Here's how you might modify your existing code to display multiple line charts, one for each frequency band. JavaScript function display spectrogram data side. Const canvas ID equals spectrogram. Yep, you're spot on. Chart.js doesn't have native support for heat maps. However, you can still create heat maps using chart.js with a bit of customization or by using extensions/plugins specifically designed for that purpose. One popular library that supports heat maps natively is plotly.js. It offers built-in support for creating interactive and customizable heat maps with ease. Plotly.js, like any other library, will add some weight to your server's workload, especially if you're generating complex or large heat maps. However, the impact will largely depend on factors such as the size of your data, the complexity of your visualization, and the server's resources. Generally, Plotly.js is optimized for performance, but it's always a good idea to benchmark and test your application to ensure it meets your performance requirements. Plotly.js itself is open source and free to use. Since Chart.js doesn't have native support for heat maps, approximating one with it may involve additional scripting and customization. In terms of server load, it could potentially be lighter compared to using a library like Plotly.js for heat maps, as Chart.js is generally known for its simplicity and lightweight footprint. However, the exact impact on server load would still depend on various factors, such as the complexity of your implementation, the amount of data being processed, and the efficiency of your code. To generate four separate spectrograms for each region with time on the x-axis and frequency on the y-axis, you would need to process the data so that it can be visualized in the correct format. Since you're using chart.js, which is generally for simpler chart types like line, bar, and pie charts, it doesn't natively support spectrograms. However, you can use multiple line charts to simulate a spectrogram by plotting power or magnitude values of frequencies over time for each region. Below is the code modified to create four separate line charts, one for each region, where each line on a chart represents a different frequency. JavaScript slashed, this assumes you have a function to parse the frequencies from column names, e.g. LL0.59, 0.59, function extract frequency from column name, const matches equals column name dot match, return matches, parse float matches 1. Slash function to get the chart data for a particular side function. Get chart data for side, data side. Const frequencies, const values at frequencies. Populate frequencies array and create a key in values at frequencies for each frequency. Object.keys data. For each, column name equal. If const with sound starts with side, const frequency equals extract frequency from column name. If frequency equals null, frequencies.push frequency. Values at frequencies frequency equals data column name. Sort frequencies in ascending order frequencies.sort A, B, A is B. Construct datasets for chart. Const datasets e frequencies.map frequency label frequency hertz data values at frequencies frequency fill false border color get random color border width 2. Return labels data time assuming time is present and is the x-axis labels datasets. Function to display the chart for a given side. Function display chart for side. Canvas ID chart data. Const ctx equals document.getElement by ID canvas ID. Get context 2D. Clear any previous chart instance before drawing new. If charts canvas ID destroy. Create a new chart instance. Charts canvas ID new chart ctx type line data chart data options scales x title display true text time y titles display true text power. Begin at 0 true. Function to fetch and display spectrogram for a given side async function. Fetch and display spectrogram ID side. Try const response equals await fetch flash fetch spectrogram ID and side equals side. If response.ok console.error response not ok response.status return. Const data equals await response.json. Slash get chart data for the side. Const chart data get chart data for side data side. Get the canvas ID for the side const canvas ID equals spectrogram canvas dash side. Display the chart for the side, display chart for side, canvas ID chart data. Catch error, console.error, error fetching spectrogram error. Call this function for each side with the appropriate spectrogram ID. Fetch and display spectrogram, spectrogram ID LL. Fetch and display spectrogram, spectrogram ID RL. Fetch and display spectrogram, spectrogram ID LP. Fetch and display spectrogram, spectrogram ID RP. Remember to add the extract frequency from column name and get random color functions, which I assume you already have. The extract frequency from column name function is supposed to extract the frequency from a column name, and get random color should return a string representing a color in hexadecimal format for the charts. This setup will create 4 separate line charts, each with multiple lines representing different frequencies. Each line chart corresponds to one region, LL, RL, LP, RP. The power or magnitude values at each frequency are plotted over time. The y-axis represents power, not frequency, because the frequency is represented by each line on the chart. Keep in mind that this is still not a true spectrogram. If you need a heat map or a more traditional spectrogram visualization, you may need to use a different library that supports this type of chart, like d3.js or a dedicated spectrogram visualization library. The provided code appears to be structured correctly to fetch the spectrogram data and display it on canvas elements. But if the spectrogram charts are still empty, there could be a few issues at play. Let's go through a checklist. 1. Data loading. Ensure that the data fetching is successful and that the data object contains the expected keys and arrays of values. 2. Canvas elements. Make sure that the canvas elements exist in the DOM with the correct IDs when the display chart for side function is called. 3. Chart.js library. Confirm that chart.js is correctly included in your project and that you are using a compatible version. 4. Correct data structure. The data must be in the correct structure expected by chart.js. For line charts, this means an array of data points for each dataset. 5. Canvas context. Ensure that the canvas context, CTX, is obtained correctly and is not null. 6. Rendering issues. There might be issues with how the chart is rendered, perhaps due to CSS styling, visibility, or canvas dimensions. 7. Error handling. Make sure there are no errors being thrown silently. Check the console for errors and handle any that are found. 8. Chart initialization. Ensure that the chart initialization code, new chart, is being executed. 9. Dynamic data. If the data is dynamic or the charts need to be updated, ensure that the update mechanisms are in place. 10. Asynchronous timing. Since data fetching is asynchronous, make sure that the rendering code is executed after the data is successfully fetched. 11. Browser compatibility. Check if there is a browser-specific issue that could be causing the charts not to display. Assuming the data is correctly loaded and all other checks are fine, let's focus on the display chart for side function. You need to parse the received data correctly into the format chart.js expects. Here's a revised version of the display chart for side function, including hypothetical debugging logs. JavaScript function display chart for side canvas ID chart data. Console.log attempting to display chart for canvas ID'd. Ensure the canvas element exists. Const canvas equals document get element by ID canvas ID. If canvas, console.error, canvas with ID canvas ID does not exist, return. Const ctx canvas.getContext 2D. If a chart already exists for this canvas, destroy it before creating a new one. If chart's canvas ID, console.log destroying previous chart for canvas ID, chart's canvas ID.destroy. Console.log creating new chart for canvas ID with data, chart data. Create a new chart instance and assign it to the charts object. Charts canvas ID equals new chart CTX. Type line data, chart data. Options, scales. X title, display true, text time. Y title, display true, text power. Begin at 0 true. This function logs out each step to help you pinpoint where the problem may be occurring. Run this and check the browser's console for logs. If there are no logs, the function is likely not being called. If there are logs, they will guide you to the point of failure. It looks like you're trying to parse the spectrogram data and then display it in charts for each EEG region. There's an indication that your data might not be structured as expected because your datasets array is empty and labels is undefined. The issue likely lies in the getChartData for side function not receiving or parsing the data correctly. Let's debug and rewrite this function, ensuring it's called with the correct arguments. Here's the updated function. JavaScript function extract frequency from column name, const matches equals column name.match, return matches, parse float matches 1, null. Function get chart data for side data, side, const frequencies equal, const values at frequencies equals, const time labels equals data time. Assuming time is an array of time points, check if time key exists and it is an array if array.isArray time labels. Console.error, time labels are not provided as an array. Return labels datasets, iterate over columns and segregate data based on frequency for the specific side. Object.keys data. For each column name equals, if column name dot starts with side, const frequency equals extract frequency from column name. If frequency equals null and an array dot is array data column name, frequencies dot push frequency, values at frequencies frequency equals data column name. Sort frequencies in ascending order, frequencies dot sort a b equals a minus b. Construct datasets for chart const datasets equals frequencies.map, frequency label frequency hertz, data values at frequencies frequency, fill false, border color get random color, border width 2, point radius 1. Return labels time labels, datasets. Async function fetch and display spectrogram ID side. Try. Const response equals await fetch spectrogram ID equals spectrogram ID, and side equals side. If response.ok, throw new error, failed to fetch data $, response.status. Const data equals await response.json. Const chart data, get chart data for side, data side. If chart data.datasets.length was 0, console.error, no datasets found for side, return. Const canvas ID equals spectrogram canvas -side. Display chart for side, canvas ID, chart data. Catch error, console.error, error fetching spectrogram, error. Function display chart for side, canvas ID, chart data. Const canvas equals document.getElement by ID, canvas ID. If canvas, console.error, canvas with ID, canvas ID does not exist, return. Const ctx equals canvas.getContext, 2D. If charts canvas ID, charts canvas ID destroy. Charts canvas ID equals new charts, type line, data chart data, options, scales, title display true, text time, Y, title display true, text frequency hertz, begin at 0 true, maintain aspect ratio false. Make sure that the fetch and display spectrogram function is called after you've confirmed the spectrogram ID is correctly fetched and the data for each side, LL, RL, LP, RP, is correctly structured in the data object retrieved from the server. The data object should have keys like time, LL 0.59, etc., with corresponding arrays of values. From the console logs you've posted, it's clear that the time label isn't present in the data you fetched, which is causing the function to halt and not display any charts. To resolve the issues, let's ensure that the time data is correctly fetched and formatted. First, let's update the fetch and display spectrogram function to check if time is a key in the returned JSON and that it contains an array of time points. Here's an updated version. JavaScript async function fetch and display spectrogram, spectrogram ID side. Try const response await fetch / fetch spectrogram, spectrogram ID and side equals side. If response.ok, throw new error, failed to fetch data response.status. Const data equals await response.json. Make sure that time is in the data and is an array. If array is array, data time. Throw new error, time is not an array or is missing in the data. Call the function to get the chart data const chart data equals get chart data for side data side. / check if datasets are populated. If chart data.datasets.length equals 0. Console.error, no datasets found for side side. Return. Display the chart const canvas ID equals spectrogram canvas side. Display chart for side, canvas ID, chart data. Catch error. Console.error, error in fetch and display spectrogram error. This function now checks if the time key is present and is an array. If not, it will throw an error and log it to the console. Next, ensure that when you call fetch and display spectrogram, the spectrogram ID variable is defined and contains the correct ID to fetch the data. JavaScript, after the spectrogram ID has been fetched successfully, fetch and display spectrogram, spectrogram ID, LL. Fetch and display spectrogram, spectrogram ID, RL. Fetch and display spectrogram, spectrogram ID, LP. Fetch and display spectrogram, spectrogram ID, RP. Lastly, make sure that your backend server / fetch spectrogram endpoint is correctly formatting the JSON response with a time key and that the arrays for each frequency are nested within the LL, RL, LP, and RP keys, as expected by the get chart data for side function. With these changes, your application should check for the correct data structure, and your charts should populate if the data is present. If the time data or the side-specific frequency arrays are still missing or misformatted, you'll need to correct the data structure server-side before it's sent to the client. To ensure that the backend is fetching the time data correctly from the spectrogram file and that the front end can display it, you need to perform a couple of checks and updates on both the backend and front end code. Backend code check 1. Verify that your spectrogram parquet files contain a column named time that holds the time series data. 2. Modify the /fetch spectrogram route in your Flask app to include the time data in the response. If the time data is not in your spectrogram files, you need to calculate it or retrieve it from where it is stored. Here's a suggestion on how you might adjust the /fetch spectrogram endpoint to include time data if it is a separate column in your parquet file. Python at app.route /fetch spectrogram. Spectrogram ID equals request.args.get spectrogram ID. Side equals request.args get side. Existing code. Try. df equals pd.read parquet os.path.join data path train score spectrograms f spectrogram ID parquet. Check if the time column exists in your parquet file. If time not in df.columns, return JSONify error time data not found 404. Include the time data. Grouped data equals time df time.tolist. For col and df.columns, if col starts with side, frequency equals col to split score. 1 group data df col a fill no tolist hack. Replace none with 0 for numeric data. Return JSONify group data, except file not found error. Return JSONify error, file not found, 404. Hack front-end code check 1. Once the backend correctly sends the time data, you must adjust the front-end JavaScript code to correctly process this data. The front-end code seems to be well structured to handle the data if it's structured correctly. However, if the charts are still empty, it's likely because the data is not being received in the expected format. Ensure the keys of the JSON match what your front end expects. For instance, if your front end expects a time key, the backend must provide it exactly like that. Testing the flow. To debug the flow, 1. Check the network response in the browser's developer tools to see if the time data is coming through and if it's in the correct format, i.e. an array. 2. Use console.log statements to print out the data right after you fetch it to see what you're working with. JavaScript console.log data / add this in the fetch and display spectrogram function after you receive the response. 3. Make sure that the time data is synchronized with the frequency data in terms of indices, meaning that the nth element of the time array corresponds to the nth measurement of each frequency data array. Once you have verified that the time data is being sent correctly from the backend and received correctly in the front end, the above adjustments should resolve the issue, and your charts should start displaying the expected data. Sure, let's create an updated /fetch spectrogram endpoint. This version of the endpoint will include the time data along with the rest of the existing data, assuming the time information is present in the same parquet file under a column named time. Here's how you might adjust your Flask route. Python at app.route /fetch spectrogram, def fetch spectrogram. Spectrogram ID equals request.args.get spectrogram ID. Side equals request.args.get side. Valid sides equals LL, RL, LP, RP. List of valid sides. If not spectrogram ID or side not invalid sides. Return JSONify error, invalid or missing spectrogram ID or side. 400 try. df equals pd.read parquet os path join data path train spectrograms f spectrogram ID parquet. Check if the time column exists in your parquet file. If time not in df.columns, return JSONify error time data not found. 404. Initialize the response dictionary with time data. Response data equals time df time tolist. Add the data for each valid side for col in df.columns. For region invalid sides, if col.starts with region, extract frequency value from column name, e.g. ll.59.0.59, frequency equal col.split. Fill NaN values with a placeholder or interpolate if needed. Response data col equals df col fill na.tolist. Return JSONify response data. Except file not found error. Return JSONify error, file not found. 404. Certainly. Given the changes to the fetch spectrogram Flask endpoint, where time data is now included, here is how you can update the JavaScript code to work with these changes. JavaScript // This function is modified to account for the fact that time is now included in the response data and should be handled accordingly. Async function fetch and display spectrogram ID side try. Const response equals await fetch slash fetch spectrogram, spectrogram ID, and side equals dollar side. If response.ok, throw new error, failed to fetch data, response.status. Const data equals await response.json. Validate if time data is present and is an array. If data.time array is array data.time. Console.error, time data is missing or not an array for side dollar side, return. Convert time array to be in seconds if required, assuming the data is in milliseconds. Const time in seconds equals data.time map t equal t 1000 slash remove this line if time is already in seconds. Call the function to get the chart data. Const chart data is get chart data for side time in seconds. Pass time in seconds instead of data.time if conversion is needed. Check if datasets are populated if chart data.datasets.length equals 0. Console.error, no datasets found for side dollar side, return. Display the chart, const canvas ID equals spectrogram canvas side. Display chart for side, canvas ID, chart data. Catch, error, console.error, error in fetch and display spectrogram, error. Function to extract chart data for a side has been modified to accept time data. Function get chart data for side, data, side, time labels. Const frequencies equals, const values at frequencies equals. Iterate over columns and segregate data based on frequency for the specific side object.keys data. For each column name equals, if column name.starts with side, const frequency equals extract frequency from column name, column name. If frequency equals null and an array dot is array, data, column name. Frequencies dot push frequency, values at frequency equals data, column name. Sort frequencies in ascending order, frequencies dot sort, AB equals A minus B. Construct datasets for chart const datasets equals frequencies dot map, frequency label, label frequency hertz, data, values at frequencies frequency, fill false, border color, get random color, border width, point radius 1. Return labels time labels. Use the time labels passed to the function datasets. Make sure to call fetch and display spectrogram with the correct spectrogram ID after it's fetched. Example, let spectrogram ID equals. Assume this is fetched correctly from somewhere fetch and display spectrogram, spectrogram ID, LL. Fetch and display spectrogram, spectrogram ID, RL. Fetch and display spectrogram, spectrogram ID, LP. Fetch and display spectrogram, spectrogram ID, RP. Make sure you replace the placeholder let spectrogram ID equals with the actual code to fetch or retrieve the spectrogram ID. Additionally, if the time data from the backend is in milliseconds and you need it in seconds for the chart, you can use the line that converts the time array. If the time data is already in the desired unit, you can directly pass data.time to the get chart data for side function. The error you're encountering indicates that the charts object is not properly defined or accessible where it's being used. Let's define charts correctly and make sure it's available in the scope where it's being used. You need to declare charts as an object outside of your functions at the top level of your script so it's accessible throughout. JavaScript, at the top of your script, define charts as an object. Let charts equals. This charts object will be used to keep track of your chart.js chart instances. It seems like you had the right idea, as there are commented out bits where charts was used as an object. After declaring charts at the top level, ensure that the display chart for side function uses this charts object to store the newly created chart. JavaScript function display chart for side, canvas ID, chart data. Const canvas equals document get element by ID, canvas ID. If canvas, console.error, canvas with ID, canvas ID does not exist, return. Const ctx equals canvas.getContext 2D. If a chart already exists for this canvas, destroy it before creating a new one. If charts canvas ID, charts canvas ID destroy. Create the chart and store it in the charts object. Charts canvas ID equals new chart ctx type line data chart data. Options: skex title display true text time. Y title display true text frequency hertz. Begin at 0 true. Maintain aspect ratio false. Lastly, you need to make sure that you're passing the correct spectrogram ID when calling fetch and display spectrogram. You should obtain this spectrogram ID from the appropriate API call or user selection before trying to fetch and display the spectrogram. Here's the section where you need to fetch the correct spectrogram ID and then use it. JavaScript /. After fetching the spectrogram ID, call the display functions. Get spectrogram ID, EEG ID, sub ID, then spectrogram ID if spectrogram ID, fetch and display spectrogram, spectrogram ID, LL. Fetch and display spectrogram, spectrogram ID, RL. Fetch and display spectrogram, spectrogram ID, LP. Fetch and display spectrogram, spectrogram ID, RP. Else, console.error failed to fetch spectrogram ID. .catch error console.error, error fetching spectrogram ID, error. In the above code, I'm assuming getSpectrogramID is an asynchronous function that returns a promise which resolves to the spectrogram ID. You'll need to modify getSpectrogramID accordingly if this isn't already the case. Make sure to define getSpectrogramID to return a promise that resolves with the spectrogram ID that you need for the fetch and display spectrogram function. Here's a quick sketch of how that might look. JavaScript function getSpectrogramID, EEG ID, sub ID, return fetch getSpectrogram ID, EEG ID, EEG, and sub ID equals sub ID. Then response equals, if response.ok, throw new error, response not OK, return response.json. Then data will return data.spectrogram_id, assuming the response JSON has a spectrogram ID field. Remember to handle cases where the spectrogram ID might not be fetched successfully. All right, we've tackled a couple of issues in your code, and here's a rundown of what we've done and why your spectrogram might not be displaying. 1. Defined charts object. There was a reference error because charts wasn't defined where it was needed. By declaring charts as an object at the top level of your script, it's now available in the necessary scope to hold references to your chart.js instances. 2. Ensured canvas exists. We've included checks to ensure the canvas elements exist before attempting to draw on them. This is crucial because trying to draw on a non-existent canvas element would throw errors. 3. Corrected chart data assembly. The getChartDataForSide function now correctly constructs the datasets for the charts by segregating data based on the side and frequency. It also correctly handles the time data, assuming it's provided correctly from the server. 4. Handled time data. We've added validation to ensure time is present and in the correct format, an array, before proceeding with chart construction. If time isn't provided properly, the function will log an error and stop the process. 5. Updated fetch and display spectrogram. This function now includes a more robust check for the time data, including its presence and type, before proceeding with displaying the spectrogram. Now, in general terms, if your spectrogram isn't displaying, it could be due to the spectrogram ID is not being fetched correctly or at all. The response from the server does not contain the expected time data, or it's not in an array format. The canvas elements specified by ID do not exist in your HTML. There's no valid data for the given side, LL, RL, LP, RP, in the response to create datasets. There could also be network issues, server-side problems, or incorrect handling of asynchronous operations. As we wrap up this overview, if you have any comments, questions, or need further clarifications, feel free to let me know. And if we were live streaming, this is where we'd sign off, invite final comments, and thank everyone for joining the session. We'd let them know to stay tuned for updates and encourage them to keep experimenting and coding. That concludes our session for now. Thanks for tuning in, and happy coding.